Alright guys, so today we're going to start looking at Chapter 4. Chapter 4 is pretty much solely dedicated to us understanding the periodic table, being able to label all the different aspects of it, and then being able to use it to describe these trends we see among some of the different elements. So let's start off by numbering the table. So there's a couple of things we want to number. First we want to number the groups. So we have a couple of names for this. We have a group, or we have a family, or we can call it a column. Okay, so groups, families are the columns on the periodic table. We'll typically call them groups. So the first one we'll call 1A, the second one we'll call 2A, and we'll jump over here, call it 3A, 4A, 5A, 6A, 7A, 8A. So then we'll come down here and label it 1B, 2B, 3B, 4B, 5B, 6B, 7B, 8B, 9B, all the way through 10B here. Okay. So there are some older systems that we have for numbering the family. So if you see a periodic table in the classroom that has a slightly different numbering system than this, where it just numbers straight across, that's perfectly acceptable, but that's kind of an antiquated system. So we can also number the periods on the periodic table, so you need to know the term period. So a period on the periodic table is a row, okay, so it's going across. You typically don't see those numbered on the periodic table, but we do know that period number corresponds to the number of energy levels. Okay, so lithium on period number 2 has 2 energy levels. Rubidium on period number 1, 2, 3, 4, 5 would have 5 energy levels present in that atom. Okay, so we have the numbering system for our families, 1A, 2A, 3A, and so on, that we use quite often, but we also have common names that we use quite a bit. So group 1A, the common name is the alkali, A-L-K-A-L-I, metals. Okay. So the terms group 1A and alkali metals are interchangeable. 2A we call the alkaline, A-L-K-A-L, oops, sorry, I misspelled that, A-L-K-A-L-I-N-E, alkaline earth metals. So group 1B all the way through 10B we call the transition metals. Okay, so we'll discuss them some in this class, but we typically don't discuss them a whole lot in sophomore level chemistry. One of the interesting things about transition metals is that they have variable charges. Okay. So at the end of this chapter, we're going to learn how to predict what charges most of the elements have, except for the transition metals. They're a little bit strange in that. And they have some other strange aspects about them. So if you take my senior level chemistry class in a couple of years, we'll spend a whole chapter discussing transition metals. But for the most part of this class, we tend to leave them alone. So group 3A, we call the boron family. 4A is called the carbon family. 5A is called the nitrogen family. 6A is called the oxygen family. Agree with that oxygen fam. 7A, they're called the halogens. So H-A-L-O-G-E-N-S. Group 8A are called the noble gases. So we call them the noble gases because they tend not to react. Okay, so very rarely do we see reactions with one of the noble gases, and they're all also gases, so that's another place the name comes from. So hopefully, remember, we already used these in the noble gas configuration when we wrote the electron configuration for our larger atoms. Okay, and down here at the bottom we have this first little weird row. We call this the lanthanides. Okay, and that is the horizontal row, and the last row we call the actinides. So if you scan through the table, you probably see where the name lanthanide and where the name actinide came from. So a lot of versions of the periodic table, you'll see elements number 57 and 89 actually down here with this block. Okay, so this block of the periodic table actually belongs right here in the center. Okay, but that would make the periodic table so large it wouldn't easily fit on paper. So this was a way to remove this block and bring it down here to the bottom to make the table more manageable. So just be aware if you ever see a table with a gap right here and these two elements down here, that this whole block actually belongs up in the table. But we don't do a lot of chemistry with these elements down here, so it's perfectly fine for our purposes that it is dropped down to the bottom. Just be aware of the special names that we give the lanthanides and the actinides. You'll also see it called the lanthanide series and the actinide series. Okay, so we discussed in a previous chapter that this first little block of the periodic table, let me get some colors. So this little block of the periodic table that I'm coloring pink, we call the S block. Okay? And hopefully you remember we call it the S block because the electron configuration of all the elements in the S block end with an S sublevel having an electron in it. So then if I come over here and I color in this big section of blue, we call this the P block. Okay, so hopefully you can figure out, or you remember why we call that the P block. Then I'm not going to color in the whole center section. Well, actually I guess I can. Color it orange. So the transition metals we call the D block. So all the transition metals in their electron configuration with an electron filling the D or a D sublevel. And then down here at the bottom we have the F block. I'll color in pink. And element 57 and 89 actually belong in the F block. You see those drop down quite a bit. So those are the four major blocks we divide the periodic table into. So another way we divide the periodic table is into the metals, nonmetals, and what we call metalloids. So you're probably familiar with the terms metals and nonmetals. So metalloids are elements that really don't fit into either category. They tend to have properties of both. So we give them a special name, the metalloids, and they kind of fall halfway between the two groups on the periodic table. So I'll circle the metalloids here. We have boron, silicon, germanium, arsenic, antimony, beryllium, astatine, and often you'll see polonium included on that list as well. So those are the metalloids. Depending on your periodic table, you'll have a little staircase drawn kind of separating these elements out. So you can draw the staircase on either side of the metalloids to the left or the right, but you should more importantly be able to identify these elements. So now once I separate the metalloids out, everything in this area up here are nonmetals. Okay, so carbon, nitrogen, oxygen, fluorine, bromine, this entire little section, they are nonmetals. Everything else that you can see that's not a nonmetal or a metalloid is a metal. Okay, so you can see that the majority of the elements on the periodic table fall into the metal category. Let me back up. I don't know what I just said. So if they're not in these two categories, they are metals. I think I might have said metalloids. I apologize for that. But everything in these sections are considered metals, except for hydrogen. Hydrogen also falls into the non-metal category. So if you want to kind of draw a little line right there to separate it out, you can. Some textbooks you will see classify hydrogen as a metal simply because of where it falls on the periodic table, as well as a couple of other reasons, but for the sake of this class, we'll just include it with the nonmetals. And so one other name I didn't mention for the halogens, we also tend to call the halogens the salt former elements. That is because they exist in salts, and we'll talk more about what salts are in a couple of videos in this chapter. So that is the basic labeling of the periodic table. Those are the basic sections we can identify: the metals, the nonmetals, the metalloids, the S, P, D, and F blocks, the different column names, so the familiar family names, as well as the numbering system, and then the two periods across the bottom have special names. So a couple of guys that we'll talk about as far as the periodic table goes. So Stanislaw Cannizzaro was one of the first scientists who came up with the idea of determining the relative atomic masses for some of the newly discovered elements. And then Dmitri Mendeleev, who you've probably heard of before, was one of the first to arrange the elements in a meaningful way. Okay, so arrange them based on increasing atomic mass, which also happened to be increasing atomic number just because of the way they typically fall. So, this was a good idea. It didn't seem like anything special at first. You just put the elements in the order. But what he found is when he arranged them in a table form, was that there were certain gaps. So he predicted that there should be an element here, but there's not one to put in here. So it turns out the gaps in his table actually corresponded to elements that would be discovered in the future. So that's why Mendeleev's early periodic table was so remarkable, that he actually predicted quite a few elements that hadn't even been discovered yet, just on the fact that there were gaps in his table in the pattern that he had arranged his elements in. Okay, so everything we talked about in this video, eventually you should be able to label on your own periodic table, or if I ask you about a certain element, you should be able to tell me what group it's in, if it's a metal, non-metal, metalloid, things such as that.